Okay, in this last video on integration by parts, before we look at just practice problems, we want to address how we handle integration by parts with a definite integral. Right, so in the previous videos, we were looking at the indefinite integral, and our goal was to recognize or identify or name some piece of it u in the remaining dv, in which it simplifies to u times v minus the integral of v du. Okay, so I went back to the f of x and g of x form because I didn't want to, you really need to do a change of bounds if you switch to u and v, and then we always switch back. So I wanted to write it this way to be very clear. So remember, that's our u, and there's our dv again, our u times v minus the integral of v du. Okay, so in other words, we just do a part of it where we evaluate by the fundamental theorem of calculus, and then we have another integral where the bounds carry over. So it shouldn't be too big of a leap, but let's just make sure we can do it, handle all the notation and the computation. So if you remember in our chart, polynomials came above trig, so this is going to be our u, and this is going to be our dv. All right, so I'm going to come over here. U is equal to x, dv is cosine of pi x dx. So du is dx, those are our favorite ones. And v this time, if you anti-differentiate cosine, you end up with the sine of pi x all over pi. Okay, because we got to deal with that extra constant. All right, so then our integral here becomes u times v, so x sine of pi x over pi, and we're going to evaluate x from 0 up to a half, minus the integral of v, so sine of pi x over pi dv, from 0 to 1/2. So I'm just going to hold on to evaluating that till the very end, and I realize that I end up with, I'm going to write it all here, x sine of pi x all over pi minus the antiderivative of sine is cosine, so it's positive cosine of pi x over pi times that pi that's already there, so pi squared, and we're going to take this whole thing and go from 0 up to a half. Okay, so you just got to be careful with all the little pieces, the signs, the constants, the algebra, really. Now we're going to plug in our bounds. So we end up with 1/2 the sine of pi times a half, or pi over 2, all over pi, plus the cosine of pi over 2 over pi squared, minus, now we got to plug in 0. The first piece is easy. It's just going to be a 0 because of the x. Actually, also sine of 0. And then minus cosine of 0, which is not 0, over pi squared. All right, so let's clean this up. So sine of pi over 2 is 1. That little piece is 1. So we have 1 over 2 pi plus cosine of pi over 2. Pi over 2, that one is 0, so it goes away. And then we actually have a minus here, right? So minus cosine of 0 is 1 over pi squared. You can leave it like that, or you can simplify further. Now it's just a matter of practice. And sometimes you got to be creative and do some simplifying and applying other techniques as we move along and collect them, even within a problem that has integration by parts.